properly. Am I not going? Hello and welcome to all of my combo lords. Sorry that took a minute. I thought I was already going for a moment, but I'm not a tech whiz here. I've been busy studying these things called automorphic numbers rather than learning about tech. And that's going to be the topic of today's stream, are these automorphic numbers. Which is a number family that we just passed one of in subscribers here. 90,625, which of course is super awesome that we passed that, because today is also actually exactly 5 months I've been posting on this channel, which started out as just a bonus channel for my main combo class channel, but has sort of just become my Demotro channel for me to have a little more blast of knowledge and fun for folks that's maybe a little less cultivated or perfected than my main channel, but you get a bunch of stuff here. And we've gotten up to this 90,625 subscribers, which actually is a more interesting number than 90,000 possibly. Well, that could be debatable, because 90,000 is the square of a triangular number, which also makes it the sum of a bunch of cubes. So 90,000 is pretty neat. However, it gets extra credit by being one of the 10,000s. But numbers that are thousands or illions may only pop up a lot based on us living in a base 10 system. Maybe there are other numbers like 90,625 that are secretly just as interesting or more interesting. And this number's traits are base dependent as well. It does rely on base 10 to do the magic we're going to see. However, those who know me may know that I am not as instantly captivated as a base-dependent trait as a base-independent trait, because some traits about numbers or life are true regardless of how you write down things, and other things rely on how you write down the language, including a mathematical language like our base 10 system. And although I don't find it as instantly captivating, or I don't instantly know it has as much depth if it's base dependent, it still gives you a good chance to wonder, would a similar property hold in other bases? And we will find that the property of automorphic numberness, and I don't just want to call it automorphicness or automorphism or something, because that's a term that is used for many things in math. If you just look up automorphic, you will get other things probably before automorphic numbers. But automorphic numbers do show up in other bases as well. Not every base, but there are bases where they happen. And so we will see that after we investigate the ones that we will find stuck in our base 10 system, such as 90,625. Now, why would this number be interesting? Well, I have a calculator pulled open here, and we're going to have to start smaller with the last digit of this number. And we're also going to start with a question, which is, which one-digit numbers, if any, when I raise them to higher powers, by which I mean taking them squared, then cubed, then fourth power, and etc., keep their number as the last digit? Now, we'll find right away that 1 and 2 and 3 are too small in our base to do that, because their square is a different digit. So they fail the first test, the square having the last same thing part. And some other numbers we'll find don't work either. But from the squares, we'll notice that 1 does it. I mean, yeah, I guess when I say 1, 2, and 3 are too small, 1 isn't too small. 1 is right at that trivial level where it hits itself. So technically, all powers of 1, although they don't grow, do contain it, so it is a trivial example of that. And the other numbers that could work, apart from arguably 0, which we're not going to allow the 0th power on these anyway, because that would break the rule. The numbers we're about to show to the 0th power wouldn't end in their digit. So we're saying powers 1 and upward. So arguably 0 and 1 are the trivial cases there. But 5 and 6 are less trivial cases. If I take 5 squared ends in 5. If I take 5 cubed, ends in 5. 5 to any random power, ends in 5. Same with 6. 6 to any random power, ends in 6. So that's one step of our interestingness here. But from the powers of 5, they have a different sort of scattered pattern than the exact thing we're going for. We're not going for cubes and fourth powers of just the number 5. This trait relates more to squares, but in a way that we're going to expand our number. What I mean by that is, let's square 5 and see that now it has a 2 in front of it. And now let's try and square this 25. And we still now have the original number at the end. 25's at the end there. And now we got a 6 in front. So what if we square that? Well, now we have this whole longer number. Now, we can't get too greedy and try squaring that whole thing. That actually won't work. But if we extend just a little bit at a time, maybe we'll have some luck with this pattern continuing. We can't just extend one digit in this case, because 0625 is the same number as 625. So we'll add the 9 as well, and try squaring that. 90625, the thing at the end there. And what do you know? 90625 squared ends in 90625. And let's string on the 8. And that ends in that as well. And we can create, if you put your mind to it, any length of number that would have this property. And this any length of number will either end in this exact thing, or will be one of the trivial examples of 0 or 1 with a ton of leading zeros, which is a very trivial example there, or will be a family related to the 6 that we noticed also squared to contain itself as the last digit. Now, to look into these families, let's see the ones that are the 5 family of this sort. Here's a list of them. We got 5, then 25, then 625. Now, 625 comes again because it's on its way to be 90625, and this one technically is 0625, which the 0, doesn't need to be written here, but it is the 4-digit version of the incarnation, because each of these smaller strings are for the nth string, the 5th string here, for example, the last 5 digits of the later strings. And here on the 4th one, the last 4 digits of the later string, 0625, leaves you with that one twice. Now, what about the other family? Here is the family with 6s. It actually has the same property, where any number here, if you square it, you get a number that, and you don't always get just the next one, because squaring them is going to be a lot bigger. But if you square any of these, you get a number that ends with themselves. And in fact, the only numbers in our base that have this property are 0, 1, and any of the numbers in one of these 2 infinite families, the one with 6s at the end and the ones with 5s at the end. And for fun, here is a list of them back and forth. And we can note that each of them have a 1-digit, or for any digit length, each of them have one number of that digit length, except since this list doesn't show repeats, sometimes you don't see one for a digit length if it has a 0 after that. Like here, we don't see a 5 ending one for the 4-digit strings because the last 4 digits of the 5 cluster has a 0 there. And this is a list of all of the automorphic numbers in base 10. I mean, obviously, you would have to continue the list. It's an infinite list because of those families, but this is, if we continue those families in forever, that would contain all of the automorphic numbers in the base. And here, we got the first 28. And what about if we looked into other bases? Well, luckily, Wikipedia has a table of automorphic numbers in different bases. Now, they're calling these b-adic numbers. This is related to something that's more commonly called p-adic numbers, which are a really cool topic that I will go into at some point in some episodes. And when I go into those, will probably be the time where I will explain to you guys how we might generate more of these and why they're using all this crazy language to call them fixed points in this realm and fixed points in this function and so on. So, in base 10, our numbers are an infinite trail of zeros that if you truncate it at any point, it just gives you the number 0. An infinite string of zeros with the 1 at the end, which if you truncate it at any point gives you the 1. Or these two infinite strings that if you truncate them at different points give you different automorphic numbers because the numbers come from these infinite strings. Now, when we look at other bases, we'll note that they say, or they don't say it right here, but they say it somewhere above that for it to work in a base, the base needs a few factors. Where do they mention that? I'm not sure, maybe I read that somewhere else, but we'll notice here that these are bases that are composite. These are bases that are composite and not squares of primes either, are the ones that we notice have it here. So in some bases where it works, we get, and the condition essentially is we need 2 prime factors. And I think we need 2 distinct prime factors because we don't see 4 and 9 on this list. And distinct is a good term in math to mean ones that are different from each other, because different can be ambiguous. You're like, here I have 2 different letters. Could mean that you just had written 2 letters, but they could be the same letter, or you could be meaning they're different. I don't know. Different's more ambiguous. And as you may be able to see, we have a visitor. So we're going to make this large for one moment to say hi to our visitor. Dandelion. Come here. Dandelion is a very sweet and fluffy cat, as some of my viewers know. And he will keep us company here for the rest of our stream. Probably. He likes hanging out here. So, I'm going to shrink again, and we'll go back to this. And looking at these different bases, they wrote the automorphic numbers in the base. So we can see that, these are the infinite strings that the base would have. And then these are the strings cut off at different points from the end. So very similar to our base. If we look in base 6, where only the digits from 0 through 5 live, we can see that in addition to having the 0 and 1 trivial ones, they have this one, for example, where 3 is if we square 3, it ends in a 3 in that base. And then the number that base 6 knows as 13, which is 9, if we square that, we get a number ending in something they would write with 13, and so on. So, And yeah, Voider, who mentioned that, he did mention this. I was planning on doing this already when we saw it on the list of a bunch of Wikipedia numbers we were going through on a stream. But thank you for the recommendation. Definitely suggested it too. And yeah, the 10 adic numbers will come into play when we look at the p-adic numbers, although the p in the adic does relate to the prime ones having special traits. Um, but yeah, very interesting number systems. And thank you all for joining me and leaving some comments. We're going to move on from our automorphic numbers for a moment because that was most of what I had to show you about them. So feel free to leave any other thoughts in the comments before I jump to our other topics. And one question here was, are the square roots of primes all imaginary or irrational? Now, it's interesting that you say imaginary in there because the square root of a whole number like a prime may have a negative one, but we don't need to bring imaginary into the mix. The square root of 5, for example, has a principal square root that's a little more than 2, and then it also has its other square root, which is a negative version of that. But as for a square root of an integer, we are guaranteed that it will either be another integer, another whole number, or that it will be irrational. It will never be a rational fraction that sort of is in between those two conceptually. So basically, we'll never be able to like square root a whole number and the answer is like 4 2/7 or something. It's always either going to be irrational, can't be captured in a fraction, infinite, non-repeating decimal, or it's going to be another whole number if it was a square number to start. Now, since square numbers are not primes no square numbers are primes, then the square root of a prime would always be irrational. So that's interesting. We also can note that square roots of integers are very special with some traits they have with continued fractions. And for example, let's go here and look on this online calculator because I believe they will let me see a continued fraction representation. We're going to look up the square root of 5 and we're going to see if they can give us a continued fraction of that. And do you see how if I repeated this forever, this approaches being exactly equal to, and when we continue it forever, we can say the limit is, and when we write a continued fraction, it equals the limit of that, is square root of 5. Now, you see how they wrote it just like this, 2, semicolon, 4 with a line over it? That's because the 4s all repeat. So kind of like how some decimals need to have like 0.4444 repeating. This has a 4 repeating in a different way. But it's even more interesting because with the decimals that have that repeating thing, they would have a finite continued fraction that doesn't even need to repeat. The repeating here was because this isn't a fraction, and because we had to get it with an infinite fraction because it's an irrational number. And so some types of irrational number, like this square root of 5, and in particular, square roots of non-square whole numbers do this. We can just write like that. And it basically puts these continued fractions a level above decimals, where they have a finite version whenever the decimal might sometimes need an infinite repeating, and then they have a repeating version for some of the cases that decimals need a non-repeating infinite. Now, it is true that people have mentioned they are harder to do arithmetic with. Of course, it's possible, but there's a lot of benefits and superpowers to them. And to those who haven't seen, there is an episode about that, about infinite continued fractions on my main channel. So look at that if you want to see the infinite ones for pi and e and stuff. So, hello to everyone joining here. Oh, it's hello to the fella who used to be named Combo Class Bonus 2. I know that your family made you change that name, it looked like from a comment, but just so you or them know, I didn't mind. I thought it was funny. Combo Class Bonus isn't really my brand. Combo Class is my brand. This channel just happens to be called Combo Class Bonus. In fact, I might change the name at some point to be more, have like Demotro in the name. But yeah, I didn't mind that you were called Combo Class Bonus 2, although it was very surreal at first. But hello, I'm glad you're interested in numbers. Keep that up. And hello to everyone else. Thank you. And Combo Class Bonus 2 bonus has joined the chat as well. That did become a great gag where some of the viewers began making further levels. So I will say again that if you put Combo Class Bonus and then a number and then whatever words you want, we'll know it's a joke, and I totally endorse it. You can even put videos on the channels. You can put clips of my videos on any channel if you put credit or a link to my stuff in there. So thank you to whoever decided to make Combo Class Bonus 2 bonus to take that to the next level. You know, we need further extensions, like, you know, then at some point there'll be Combo Class Bonus 2 bonus, the sequel, Combo Class Bonus 2 bonus extra. You know, there's always further levels you could take that. So it is funny because it's already further levels. Combo Class Bonus was already a level deep because the show is called Combo Class. So, in any case, that was a funny thing from the past little bit. As far as some Combo Class updates, because it is the start of a new month, and so I might as well give you a little peek at what we may have coming this month. Well, almost done filming the Pan-Digital Numbers episode for the main channel, which I'm going to finish filming tomorrow. So that'll be out Friday or Saturday on the main channel. Will be super cool. Pan-Digital Numbers are numbers that contain every digit in some given base at least once. And we're going to learn a lot of interesting stuff about them. And then there will be a few more episodes on the main channel this month. There will be either 3 or 4 there on this month, where usually there's like 4 or 5 per month. Because I need to take my time with these final grade -1 ones, where there's only 6 more main channel episodes in grade -1. And grade -2 will probably be coming at the beginning of April, which will require a big transition, which is good because I need a new desk and I need a haircut and I need a lot of stuff that got destroyed by the rain out there. So, time to reset and get grade -2, even cooler, maybe a little more professional looking and sounding without losing any of our chaos. And apart from those coming this month, and apart from the usual bunch of shorts and live streams and bonus videos, of which I did also put out a bonus video today for anyone who didn't see. You can watch that after the stream. It's about factorials and clocks and diving into why and how February has exactly 8 factorial minutes. And just some random facts about February. And some of the other things planned this month are for my people who are helping me on Patreon. apart from some bonus videos, one of the other things I'm going to put out a rough version of there before I put out a more polished version for all the rest of you. At some point before long, will be released to all of you, will be the soundtracks that I put in the back of the main channel episodes, which are beats I made. So people have asked for the soundtrack, which I will give you guys those at some point, starting with my Patreon folks, just the rough versions of them that I currently have. The rough versions of the songs, not the rough versions of the followers. So someone's wondering if I have a favorite non-decimal number system. And apart from base 10, don't worry, we don't need to say, if you mean like non-base 10 as far as decimal being like an official name for that, you don't need to even say the non-decimal part. If I pick a favorite number system, it won't be base 10. Don't worry, base 10 is not going to be on the top 3 list. So my favorite, for a while, I saw the advantages of base 12 over base 10, and it is much more efficient. But I mostly heard about that first because it's more popular. People can envision adding the digits more than they can envision subtracting the digits. And for some reason, they're really scared about some numbers taking like one more digit to write. But all of that would be balanced out and more by the fact that base 6 secretly has a condensed version of base 12's patterns, and at that sacrifice of some numbers taking like one digit more to write, big deal. How often do you need to deal with numbers in the tens of thousands anyway? Everything else is benefits with base 6. Everything that's good about base 10 is even better with base 12, and all of that is either just as good with base 6 or better. Some of the patterns are neater than base 12. Like, for one random example is some of the fractions behave better, and that's because not only is 6 composed of 2s and 3s that make it really good at dealing with like 2, 3, 4, 8, and so on, but 6 also is right next to 5 and 7, the next primes after 2 and 3. And when your base is right next to numbers, the number that I call B minus 1 or B plus 1 for your base number, those numbers get special powers. Like 9 has special powers in our base, 11 has special powers in our base, and they are easier to deal with their fractions being turned to decimals. They're easy to deal with other things in times tables and divisibility. And so that would be 5 and 7 in base 6. And that's pretty good because with base 12, it gets those for 11 and 13. And it's not as good at doing stuff with 5s and 7s. In fact, the fact that 5 and 7 are co-primed to 12 and have no factors bigger than 1 in common is something that will show up in many episodes, because I have this animation I got that is about these spiky shapes that this guy, the Magic Fella, made for me. Shout out to him. And the spiky shape animation that you can imagine as having like a clock that you paint to 5 hours forward and then 5 hours forward and then 5 hours forward and paint out that star shape, which if you did it with 7 hours instead, it would be that in reverse. That actually has to do with musical scales also, and has to do with these things called fairy series that are the ways of enumerating fractions that I mentioned in a short but didn't mention that connection, and a lot of other rare cool stuff. So I would say my favorite for humans to use would be base 6. However, some of my personal favorites, not in terms of recommendations for humans to use, but in terms of ones I find really fun, are some of the ones I've made episodes about on my main channel that include the golden ratios base, include bases that are square roots, include bases like base 2i, base I minus 1, and some really wacky ones. Balanced ternary that I haven't covered yet, but there will be an episode about in grade -2, and a bunch of other cool ones like that I've done in my obscure bases series-ish episodes on my main channel. And so those are also my favorites in terms of them being really fun and having unique superpowers. Like some of those can do things that the normal positive integer bases can't do. But for humans, I'm going with base 6. All right, now we have combo class bonus, the sequel. And that one sounds good too. And all of these, whether it's numbers or the sequel or bonus or extra or things tacked on, do make funny additions. So anyone who wants to join and make a weird channel, you can feel free. You have my blessing. But make sure that you the only rules are if you put anything on the channel, follow the combo mentality, be chill, be a good person. If you're bringing anything to the world with the channel, you got to do good things with it, or neutral things, just not bad things. And you can even feel free, like I said, if anyone wants on any of their channels, to post any of my clips. I have tons of content that I've never edited into like shorter videos or shorts or anything. And if anyone wants to use any of my content, as long as they credit me, they can feel free. And the only other rule about the bonus channels is make sure it says bonus. Don't just say like combo class something. Because what if I want to someday start a channel called like combo class that, So we'll have bonus be our establisher that those are our bonus channels. And when I made the first bonus channel, I didn't know that bonus was going to get so bonusy, but here we go. And like I said, it's only been 5 months I've been posting videos on this channel. Slightly longer on the main channel, only like 1 or 2 more months on a few more months on the main channel. But it's only been 5 months I've been posting on this channel. Although I had been filming some of the shorts a few months before that. But nothing that was on this channel was filmed a year ago. And so this is rising quite quickly and awesomely. And to anyone who for some reason doesn't know, we also do some cool chatting on the Combo Class Discord and subreddit, which are linked in the description here. Someone mentioned that B+1 has certain perks, or that they said that I mentioned that. And they know 9's divisibility rules, but does 11 have similarly easy ways to check for divisibility? Now, you kind of got to do this alternating digits thing. I mentioned it in an episode about palindromic numbers on my main channel a while ago, because it's this alternating digit test that's a little harder to do and not as simple, but you could still do relatively quick, where you have to add and subtract digits, or in other ways of phrasing, you can separate the digits into 2 halves and see their difference. And that way is sometimes easier to split the even and odd digits and see their difference of their sums. And the reason that came up in the palindromic numbers episode is because it turns out that certain palindromic numbers, if they have, for example, certain even numbers of digits, must be a multiple of 11. And it's why when you look at a list, if we go to the OEIS and we look at palindromic numbers, and let's hope that they have a list of this. And of course, this is again a base 10 pattern that you could look deeper into if you look into other bases and see what palindromicness means in general. And in my episode about them, I did find and unveil a lot of facts and things that were about based independent traits about palindromic numbers, or traits that hold true in a wide variety of bases. So here on a list of the palindromic primes, oh, here they go. They're even saying it. So they often have awesome notes. They're saying exactly what I was going for here, which is that every palindrome with an even number of digits is divisible by 11. So 11 is the only member of the sequence with an even number of digits. And you can notice that there's no 4-digit ones here, and there wouldn't be any 6-digit ones. And that is one of the traits that can hold true in other bases as well. So if you look into other bases, you're going to be looking for odd digits of palindromic primes. But you guys can see my full episode for more about that. And no, I have not released the petition for Threven and Throd. That will be a little while. That'll be a few months out because I need to culminate and comb through a bunch of research I've done the past year about them and find the catchiest facts and the most quotable parts about it. And I need to try and make a Wikipedia page full of those facts. And then I need to try and make a petition. So don't rush to do it. There's still more we can do for Threven and Throd. We just have to be saying it in our daily vocabulary and then seeing that if any journalists out there can include it within any of their writings anywhere, that'll be extra helpful. And so just getting Threven and Throd more widespread will help for now. And the petition will come once I have that research ready. So, and as far as 11's divisibility, there also was just cool things it does with multiplication, easy patterns on times tables, and things like that. So, thank you all for joining me here. We already did our automorphic numbers thing, and we're not going to do a super long stream today, but we can find a few more interesting things to look at. Now that we've passed 90,625, let's take a little peek at what other interesting numbers we're going to pass on our quest to 100,000. Now, if we can get to 100,000 in grade -1, that would be absurdly cool. I'm not even counting on that. If we get there in early grade -2, that is still absurdly cool. But in any case, on our quest to 100,000 subscribers here, we're going to pass a few numbers, and here let's look up Wikipedia's list of numbers around the 90,000 to 100,000 range. By the way, when we were looking at which number was the smallest that didn't have a Wikipedia article about it at some point, which was one possible way you could measure the silly question of smallest uninteresting number, or which it becomes paradoxical, so more so what is the most uninteresting number in a given range. And I did find that data. That was, if I looked up, what was that? List of numbers. So list of numbers, great name for a page. You know I'm into that. So here you got your natural numbers, and then you got your, what else you got? You got your primes, you got your highly composites, you got your perfect numbers, and wow, what do you know? Primes are extra special in their own way, but 6, the number I love, is on both of these other lists. And it's made by multiplying the first 2 on this list. You got your integers, you got your rationals, you got your irrationals. Oh, whoa, zoom in. You got your algebraic irrationals. First, you got your transcendental irrationals. You got your irrational, but not known whether they're transcendentals. You got all of these fellas. And whoa, and then you get crazy. You got your hypercomplex numbers and crazy stuff down here. Wow. So back up to our natural numbers, we can see that it turns out the smallest number that appears to not have a Wikipedia page is 198. They don't have an article for 198. And that's the only one they don't have an article for up through 264. Which I bet you if you pulled someone random on the street, something about the evenness about those numbers, or the way they look like almost multiple of 2 like, that people would guess that those are more important, like 264 or 198. Those are the first missing ones. And we can see that 197 had some traits. They wanted to say it was part of a prime quadruplet. They wanted to say that it has these other prime traits and it's a figurate number of these types and then some other stuff. And 198 they do have on this list. So that, I guess, kind of counts. That maybe half counts because has a little subheader on a list. So it has that trait and those traits. And what's the smallest one that doesn't even have that, we could ask. And if we go back, we can see, does 264 have one? It does. So we did a little quest the other day to try and guess if we could find the one that doesn't. But, does this whole range, 264 and all those, 5, 6, 7, 8, 9, they do all. So what about the next range? 272? I'm not seeing, is it there? Oh, they have it. Okay. So it'll be a little further, I guess, but 198 is the smallest number that doesn't have its own article. Now, of course, articles can also be based on them being full of something cultural about that number, so it's not purely mathematical. But, that one was missing. And the other day, in one of the other streams, we did another dive scrolling through these, so we'll come back to this longer sector of the list later. For now, we're going to look at the 90,000 section. And here we go. The only one in the 90,000, how do you describe that? The 9D without being a higher digit there, 1,000 range. It's kind of hard to describe. The 90, because you could call this the 91,000s, but you can't call this the 90,000s. That's all of them. But the only number in the 90,000 to 91,000 range that they mentioned here is this, the only 5-digit automorphic number in our base. So we will also be passing 45 cubed, this thing called a fine number, 6 cubed plus 6 to the 6 plus 6 to the 6, and also a 3 smooth number, meaning it only has 2s and 3s in its prime factorization, a palindromic square, these type of numbers that are confusing because there's another one called a Capricar type constant or a Capricar. I've even heard it called just numbers generated by Capricar's routine and various names. So the stuff this guy invented, they named confusingly. And we got some more random ones. I do like these 3 smooth numbers. Smooth numbers are numbers whose prime factors have none greater than some certain number. So like a 7 smooth number has its prime factors are all 7 or lower. So a 3 smooth number means a number whose prime factors are all 3 or 2. And those are pretty cool because they are super even-threven E numbers. And they're numbers that would do quite well in a base 6 or 12 system. So, a lot of fun stuff we will be getting there slowly and steadily. And I think I am going to wrap up the stream relatively soon, so feel free to leave any comments or thoughts. We will be back for a lot more soon. I'm going to be, like I said, finishing filming an episode about pan-digital numbers tomorrow, so I'll see what I get up to as far as streaming or shorts or other stuff. But those will come before long too. And then that main channel episode will be coming out on Friday or Saturday. And someone's asking, do I know much about Harshad numbers, which are numbers divisible by their digit sum in some base? And I do, and there will be an episode focused on those. I've already made a few shorts that or maybe just one short at least that those have come up in. And there will be an episode about those at some point. Not necessarily purely about those, but an episode about traits like that related to divisibility of digits and digit sums. And digit sums can actually be one of those interesting ones that, like I have mentioned in this stream once or twice, have that trait of starting out being a little less deep because they're base dependent. They rely on whatever base you write them in and change with a different base. But you could look for patterns with them of rules that hold true for any base, or sometimes for a large range of bases, or an infinite range of bases starting at a certain point, or various things like that. So, in the episode we do about those, of course, I will be bringing in properties that things like Harshad numbers would have if we wrote our numbers in other bases. And good luck to the comment who is studying for their test. And hello to everyone saying hi. So, I'm going to log off very soon. We can get one last pet on our gentle little Dandelion back here, who is so soft, and I will be giving a lot of pets to after this stream, because he's a very good boy. And hope you all have a super good day or night, whatever time it is where you're at, and a good start to your February. Remember that February has fewer days than other months. Like I mentioned in the bonus video I put out today, that can be good or bad for certain things for the ratio you get. It's less of a ratio of time, but that doesn't really matter when they call it the next month. But some things do run on a monthly cycle. For example, if you are getting paid a monthly amount from a job, well, you're probably going to work less days in February than the other months, so you're getting a higher rate. But if you're paying rent monthly, you're getting your worst rent month on February. You're only getting 28 days for that rent. So, I know it's shorter in February, so I'll be making sure to post extra cool stuff on my Patreon for the people who that is a monthly thing. So make sure to take advantage of whatever monthly things that you have. And thank you all for joining me. Extra special thanks to the people on that Patreon, who I'll have some more bonus stuff for soon, and those soundtracks for before long. And I will catch you all in the Discord or the subreddit, or in our next chats and things like that. And someone also asked about the sum of the natural numbers, and we'll cover that at some point, but don't get too excited about it being negative 1/12, because based on a normal sum, the sum of the natural numbers is just one of the types of infinity. And thank you to Quinn, who's saying the Patreon is pretty cool, guys. He is definitely right. There's been a lot of fun stuff I've posted on there so far, like sneaks previews of my cameraman, of longer cuts of some of the campfires from episodes, and various stuff. So, love you all, and I will catch you again in the next one. Time to give Dandelion a lot of